Alright guys, today's essential question is, how do we identify the zeros and y-intercepts of a polynomial function? Guys, just keep in mind the zeros are also known as the x-intercepts. And if you remember from day one, the degree of your polynomial tells you at most how many zeros or x-intercepts you'll have. So for example, if I give you a polynomial function of f of x equals 3x cubed plus 4x plus 7, since the degree of this polynomial is 3, then I would say that at most I could have 3 x-intercepts. Could be less, but definitely won't be more. Alright, so we're going to tie everything together about what we've been covering for the past few days into 3 examples. Let's take a look at this first one and go straight down. My function is 2x cubed minus 9x squared plus 12x. Here's the graph. Notice it says type of graph. Is it even or odd? Well, the degree of my function is 3, which means it's odd. I could have also told it was an odd degree by looking at the end behavior. If your end behavior is going in opposite directions, the degree is odd. Now, if you look at the leading coefficient is 2, so that means the leading coefficient is positive. So, end behavior-wise, notice it's going down on the left and up on the right. If we write this out using function notation, this would be as x approaches negative infinity, in other words, on the left-hand side, my function is going to negative infinity because it's going down. As x approaches positive infinity, so on the right-hand side, then that means my function is going up, so it's going to positive infinity. Alright guys, let's talk about the domain. Remember, the domain of any polynomial function is always negative infinity to positive infinity. The range, well, the range for this one is also negative infinity to positive infinity. The reason is because the range is how far low to how high it goes. Well, notice the end behavior, they're going in different directions, so it will continue going down and keep on going up. Now, there is no absolute min or max for these, since the end behavior is going down and up on either side. So both of these are going to be what we call local. But I do have a local max, it is 1, 5. And I have a local min, it is 2, 4. My zeros, remember that's my x-intercepts. It does cross the x-axis at one point at 0, 0. And my y-intercept, it does cross the y-axis at the point 0, 0. My intervals of increasing, remember, read the graph from left to right. So my graph first is increasing, then decreasing, and then increasing. Remember, always start with negative infinity and always end with positive infinity. Look at your maxes and mins and use the x values and go in order. So 1 comes first and then 2. So the graph is increasing from negative infinity to 1 and from 2 to infinity, and then it's decreasing from 1 to 2. Alright, let's take a look at the second one. Notice that this is an even degree with a positive lead coefficient, so my end behavior should be going up on the left and up on the right. If I write this out, as x goes to negative infinity, my function needs to go to positive infinity. As x goes to positive infinity, my function should also be going to positive infinity. Alright, the domain, no surprise here, negative infinity to positive infinity, but my range is different. My range is going to be how low it goes. If you notice, there is a minimum here, and it is an absolute minimum. So I'm going to go ahead and put that. My minimum is absolute, and my absolute minimum is 4.5 comma negative 2.25. So my range would be, remember, use the y value, negative 2.25 with a bracket, to infinity, because the function does keep on going up. Now, ironically, there is no maximum, local, nor absolute, so there's none for this. X-intercepts, or zeros, there's 2. One at 3, 0, and 1 at 6, 0. Notice that when you write your zeros, the number 0 is actually in the y-coordinate, and the non-zero term is in the x-coordinate. Alright, the y-intercept, it does cross the y-axis, but I really can't see what it is, but I'll go ahead and tell you that the y-intercept is 0, 18. Intervals of increasing and decreasing, notice that it is decreasing first, so then it's going to be from negative infinity to the x value of 4.5, and then it's increasing from 4.5 to infinity. Alright, last one. Notice I don't give you a function here, but notice the end behavior is going in different directions, so I know that this has to be an odd degree, and I also know that it has to be positive if I go back and look at my rules, because when the graph is, the end behavior is going down on the left and up on the right, it's a positive odd degree. So, end behavior-wise, I'd write this out as x approaches negative infinity, my function goes to negative infinity. As x approaches positive infinity, my function goes to positive infinity. No surprise here, my domain is still negative infinity to positive infinity. My range is also negative infinity to positive infinity because of the end behavior. There is no absolute mins and max. They're both local. I do have a local max at negative 2.3, 16.5, and I have a local min at 1, negative 2. I do have three zeros for this function. I have one at negative 3.90, one at 0.30, and one at 1.60. I have one y-intercept. It's at 0, 2. I'm going to read the graph from left to right. My graph is increasing, then decreasing, then increasing. Always start with negative infinity, and then always end with positive infinity. Use the x values. So the first one is negative 2.3, copy that, and then the last one's 1, copy that. So my graph is increasing from negative infinity to negative 2.3 and from 1 to infinity, and my graph is decreasing from negative 2.3 to 1. Alright, that's it for today's lesson.